Welcome to our session on automated functional testing, specifically in the aerospace and defense market. My name's Jim Nickel. I'm the Aerospace and Defense Account Executive for Eggplant Software. Spent a lot of time in this space. I'm retired Navy, spent several years as an aviator, test evaluation, naval research, then spent some time actually flying in the commercial airlines, and then finally found my way into software, where I spent about a little over 10 years at Microsoft managing aerospace and defense business, and recently come over to Eggplant. Very excited for their technology and what they're doing in the market, so I'm happy to be here, certainly. Glad that you joined us. So we'll work through some slides, talk a little bit about the A&D market, some of the constraints and challenges around both acquisition and just the nature of software. And then we'll roll through a little bit on Eggplant and how we address some of those. And we'll have some contact information at the end, so you can reach out to us for a follow-up. So probably a little bit of preaching the choir here, but I think just to level set, talk a little bit just about the attributes of aerospace and defense software, and specifically why it's a little bit different than what a lot of the rest of the world does. This is a list that was written in a study about a decade ago. I think it's still, by and large, pretty relevant, specifically to what we're talking about. I've bolded out some considerations. If you notice, probably again, no surprise to anybody on the call. You guys write a lot of stuff that's never been done before, part of trying to stay ahead of our adversaries, keep our competitive edge, operate in a stressful environment with users under stress, highly complex operations, highly trained users, but at the same time, builders don't use, users don't build, so a little bit of disconnect, and we really try to strive to really minimize the gap between the two. And then probably the last bullet is the most important. When you're dealing with aircraft, spacecraft, military operations, the stakes are pretty high. Really the critical priority to get it right is critical not only to our interest in defense, but also to those operators and warfighters that are out there on the pointy edge of the spear. Again, if we step back to A&D writ large, operate under a lot of the same constraints that any organization does, with some special considerations or maybe just a up-leveling of a few of these. So controlling costs, always a concern of a business, but specifically in the times of declining defense budgets, a lot of scrutiny on major acquisition programs. How do you effectively control cost? How do you increase and improve margins for the SI side? And if you're on the DoD side, again, how do you maintain your budget compliance and ensure that we're delivering the best possible capabilities at the most reasonable cost? Technology compatibility, probably a extra important place in aerospace and defense, just because of the broad history of legacy infrastructure, and that's the hardware that you operate on, not only in the field, but a lot of the supporting infrastructure that goes into logistics and sustainment of those systems. And then a lot of broad tools that make up your ecosystem as far as the tool chain in how you develop, how you test, and how you manage those programs. Another challenge, dynamic GUIs. The user interface tends to be animated. They tend to be complicated. A lot of times touch, a lot of times they can be hybrid, maybe a multifunction display with bezel buttons. Again, how do you test these and get that assurance that you're meeting the objectives of the software when you're testing something more complicated than a website? And then lastly, resource challenges. If you read almost any of the market reports, any of the annual reports from our defense contractors, DoD says the same thing. How do you recruit and retain top talent? How do you bring the best engineers onto your team and then keep those engineers doing things that add value to the chain? And one of the points we'll make here is having your engineers, having your software development folks really too involved in the testing, especially manual testing, is really a low value use of their time. We'd like to see if we can't push them back into creating code and getting new capabilities out, as opposed to following fairly mundane manual scripts. So when we think about that landscape for aerospace and defense, from our perspective, we kind of see 6 critical areas where automation is going to be important to maximizing mission success under those resource and cost constraints in the environment. First one off the top, tap into domain experts. We have the ability to not only create models, but those models are attached via code and snippets to drive the actual test automation and the test cases. And to any degree that we can bring experts, subject matter experts, domain experts into the conversation, have them help to build those models, understand what the flow should look like, work out the not only the predicted user journeys, but also the problematic or the critical user journeys. So that's very clearly laid out, and they've had input on that. Then we bring in our automation intelligence as really an assist. So what that does is once the model's created, once you have your paths defined and have created your user journeys, the AI will become the brain of the program. It'll execute those requirements-driven test cases and scripts, but then based on its understanding and the mapping of the model, it can take over and then generate test cases and user journeys outside that happy path. So they can iterate around the different states, the different transitions, the different places. It can be set to bias towards code coverage to ensure that it's testing all of the aspects of your code in all the states. And it can also be set up in what we call bug hunting mode, which you can think of as kind of automated exploratory testing. So without any real guidance or direction, it can be left in the corner to run, and it can really go and drive in and identify bugs and verify that they're actually bugs by confirming that they continue to show up in the same way, can iterate around this side to see what the cases are, and really package all that stuff up into a nice archive that the developers can use to go back and troubleshoot. Specific again to aerospace and defense, non-invasive automation. And so by that, we mean that we use a two-system model. We connect to the system under test via standard protocols, usually RDP or VNC. And what that means is no client on the system under test, no need to access any of the code, especially proprietary code, or maybe it's a joint venture where there's a number of different companies writing code. Doesn't matter. We'll come at it and we'll test, which leads to the next bullet. And that's that we're really testing the user experience, not the code. Code gets tested during code review, static tests, unit tests, a lot of that's built into your chain. What we're really seeking to do is come in as that more functional and user acceptance level and really test the experience. Is the actual software, is the actual capability that's hitting the end unit, delivering the capabilities that the users need. And then we wrap all that up with a package of some predictive analytics, how to know when an application or when a subset is ready for launch. And then once you do go to launch, how do you monitor that in production and continue to provide a faster turnaround to fix not only bugs, but also add capabilities in Rev and session upgrades. So if you take those challenges and then take a look at what's changed in testing, the model has really gone from that very requirements driven, I have my matrix, I've got test cases built against it that proves out that I've tested each one of the requirements, and at the end of the day I can check a box and say, yes, I tested. Today, what we're really seeking to drive to is a point that says, not that, yes, I tested, but yes, I tested and my system is meeting and hopefully exceeding its desired positive mission outcomes. And that, again, goes back to including those subject matter experts in the conversation, bringing those folks into the testing experience so that they can build test cases and build some degree of assurance that actually the system is doing what it needs to do. As a result, what we're seeing, at least in the US, is that from the Department of Defense perspective, software acquisition is changing. If you think back over the last couple of years, a lot of talk about moving to Agile, moving to DevOps, and an equal and opposite pushback that the current acquisition model, the current waterfall methodologies are really baked into the system, and that really prevents an iterative or a Agile type approach. Department of Defense has realized this. There's been some studies done. Most recently, just in this year alone, the Defense Science Board came out with a report on procuring software for defense uses. And they've had a number of findings. I certainly encourage you to read the paper. We'll make some links available to this as well. But to this conversation, I think I pulled out a handful of probably the most critical ones. One is the idea that in order to compete just at the RFI stage, the Defense Science Board is suggesting that contractors should have to demonstrate at least a pass-fail ability to construct and operate a software factory. And we'll speak a little bit to a software factory and what that encumbers in a bit. Also, the suggestion that they require all programs post milestone B to implement iterative software development processes. And again, with the supporting contracting and acquisition rules that support those minimally viable software units to be delivered, tested, and then built upon. And lastly, for the prime contractors on the call, there's a recommendation that the CEO, so this is a very senior level for the organization, should brief the Undersecretary of Defense at least annually, and they want to see a demonstrated progress on adapting these modern software practices, and again, going back to their proficiencies in establishing effective software factories. On top of that, the Defense Innovation Board recently has come out with some guidance, not only on the metrics and how you gauge software proficiency in development, but also what they call the 10 commandments of software development in defense. A couple of key bullets out of this one. Start small, be iterative. We'll see that word iterative a lot across here, and then be terminated quickly, and that's that idea of failing fast. Bullet point, adopt a DevOps culture. I know that means a lot of things to a lot of people, but again, at the end of the day, it's just how do I deliver smaller blocks of code more frequently, test earlier, and ensure that by the time we get to a deployable product, it's fully functional and we're not extending this over months and years. We're actually turning these things down in days and weeks in some case. And then the way you get there, and they point that out, is to automate the software testing for all of your critical updates and drive that timeline again, days to weeks, not months to years, and you'll see that a lot in the studies and the recommendations that are coming out of some of our think tanks. So why is this important? Again, pulling out of a lot of these conversations, a lot of these papers. Not a critique of anybody. It's a complicated world. Acquisition sometimes doesn't make it easier, but software is plagued by poor quality and slow delivery. We've seen programs fall months or years behind schedule, mostly based on software. We've seen some large acquisition programs canceled because the inability to get the software right. Measuring the health, how we use that, the idea of what gets measured gets managed. Some guidance from them on how specifically to measure some of that software development, how we change the way we look at that, and how to change the way we incentivize development to be more specific to outcomes. These are important really when you think about the world we live in today, certainly heavily in electronic warfare, but our radars, guidance systems, our C2 systems, almost anything that's got a military application fundamentally gets their functionality from software. Hardware is a long life cycle product, and our inability to meet the requirements in the field, to defeat countermeasures of our adversaries, and to stay a step ahead and ensure that our fighters have the unique and unquestioned advantage, that's all going to come from software. So really this is driving how do we rapidly develop it and get the newest, best software to the field the fastest. Next, we talked a little bit about cost and using our developers to their best advantage. The reality today, a lot of the software that's going into our systems, and there's certainly a drive again from the Department of Defense and others to push GOT software to reduce the amount of purely homegrown software. And even when that's done, there's libraries, there's open source tools and things that are pulled in. So most developers don't write most of their code. And that's a broad statement, but I think it renders true that there's a fair amount of code that's pulled from either previous projects or open source or other libraries. So how do you get functional feedback early in the process when that cost to address is low? Again, as everybody I think understands, the earlier in the process we can identify a problem or a challenge and address it, the faster it is and hence the cheaper it is. And then lastly, just to recap, based on some of the references earlier, a lot of our acquisition instructions, including the DoD 5000 series and a lot of guidance coming out of the think tanks, are increasingly calling for this incremental software release and trying to get developmental testing and operational testing shifted left into the development cycle so everything is pulled sooner and problems are addressed earlier. So what's that mean to you guys? I think that I've said here that I think it's ultimately going to mean that you're held to a new and possibly would be considered a higher standard. This is excerpted specifically from the Defense Innovation Board paper on metrics for software development. And they talk about measuring things like the time from program launch to deployment of that simplest useful functionality. And again, that goes back to that agile methodology, that idea of how do I release smaller blocks of code faster to ensure quality early in the stage and result in a comprehensive and a functional program when it gets to the field. Deploying high priority code updates, again, smaller increments, that iterative, that agile practice, breaking away from the typical block upgrades that is what ultimately tends to drive major programs behind schedule. They also look at things like how gracefully software fails, how many errors were caught and resolved in testing, and how rapidly the developer is able to patch bugs. Again, speaking about velocity and iterative and having a comprehensive test program that catches that. And then that follows on with the idea of really having Department of Defense, when it looks at acquisition and performance of contractors, what percentage of the bugs are caught in testing versus those that are caught in the field. And that's going to go to code coverage and some of the automated functional testing and exploratory testing that we support. And then lastly, they recommend that a set of automated tests will be constructed that cover not only the specifications for what the performance should achieve, based on your requirements, but is that code that is used to implement them. And we'll show you how we tie all that together. So when you think about a software factory, again, this graphic pulled from the Defense Science Board paper, this is kind of their picture graphic that shows the stack, or at least the series of operations or specialties that result in what would be called, in their terms, a software factory. In our case, talk about the metrics, talk about the challenges. So what we do, it's really testing in metrics, and that's what we specialize in. That's what we hope to help you achieve. In fact, the Defense Science Board did their research, did their talk on software factories, and in Appendix E, they had a source selection criteria, and under external test frameworks in that appendix, test plant and eggplant was called out specifically. So not only have we seen positive feedback from the Defense Science Board, had a lot of good feedback from our existing customers, which we have a number of customers across all the DoD branches, almost all of the major defense contractors and system integrators, and that goes for not only US, but the UK and around the world. Specifically out of the Forrester Wave, what put us up in the upper right-hand corner by a good bit is our scriptless AI model that we talked about earlier. We'll go in a little more detail later. The idea of extending functional testing to include early steps and that customer experience testing, again, bringing the subject matter experts into it. And then from our last experience with Forrester, some improvements we made to the way that we can do our APIs. I think that probably the best takeaway we have is that based on the people Forrester talked to, their response was that using our tools, they were able to not only increase the level of reuse, that means their scripts are more durable, but they were able to achieve automation levels of 60 to 70%, which is significantly higher than a lot of what the other tools in the field provide, and certainly higher than where most people are in their current software development lifecycle. So the way we get there, it's called the Digital Automation Intelligence Suite. It's a number of products that come together, although they all are certainly designed to work together and cover different aspects of the test automation process. Effectively, when you look at this, it's a quick overview of our tool set. The top graphic shows that iterative or the cyclical feedback that's kind of hard to see on the left there, but that's one of our AI models that drives not only the test creation, the test scripts, but also is the brains behind driving the functional unit, which actually performs the test. And so when you think about our suite, effectively it's made up of our automation intelligence, or Eggplant AI, and then we also have modules that support functional performance testing and that user experience testing. The analytics tools that go with that are real-world monitoring or our synthetic user capability, and again, all that seeks to provide direct feedback to the folks that in the modeling and the QA, and ultimately back to the developers. That can sit on top of what's called the automation cloud. A little misleading because it can be run completely on premises, and that's where our integrations happen with your existing tool set. So whether it's Jenkins, Puppet, JUnit, UFT, TBD, because we're adding capabilities all the time, and working with customers that engage with different systems and tool chains, and we're able to, through our open system, integrate with those. And I specifically call out Selenium, as a lot of people have a pretty big Selenium library, and we can certainly pull and kick off those Selenium tests through WebDriver as well. And then there's a network application or network module that allows you to run these tests under very controlled network simulations, 4G, 3G, 1 gig. I think we run about 16 different models. And again, really proving that you can have the performance and you're testing the performance in a real world environment. And then on the right there, we've got a number of accelerators that doing a lot of things. We come out across a lot of customers, and we have some accelerators and some fast starts that really help you get up to speed in building that out. And that we come with a strong team of support, and we're always happy to help, because at the end of the day, we're really just about making you guys successful. So Eggplant Functional, that's actually the kind of the core engine of our offering. That's what actually connects to the system under test. That's what executes the scripts. That's where the environment that you'll write your scripts in. You'll capture your images and your characters if you're using optical character recognition. But the idea here is that we really want to test through the eyes of the users. That's kind of our I guess our tagline for the company is how do we ensure that the testing we're doing is from the user's perspective, from the mission commander, from the operator in the field, and are they getting what they need out of the product? The other challenge around functional and automation tools is a lot of them are niche. There's ones that specialize in doing web. There are certainly ones that do mobile. There are some that are set up to do Linux, Unix mainframe type work. Again, because we come in and connect through industry standard remote protocols like RDP and VNC, we can connect to any device, any system, and a lot of times use the exact same scripts, regardless of whether you're on a mobile device or a tablet, web app, or even running embedded or mainframe code. What this all amounts to is kind of universal end-to-end test automation, including actually controlling the device. So rotating screens, interacting with complex menus, animations. If a human can do it, we like to say that we can do it. But where the real power of Eggplant comes in is what we call Eggplant AI, or our Eggplant Automation Intelligence. Again, you can construct a model of your application, pull your subject matter experts in to help build that either in the initial stages or once the application is built. Also some abilities to take what you have in functional and build a model so it is a little quicker to have something to work with. And from that point, you can modify or tweak, but it gives you a good graphical overview of what your application does. And you'll see when we run through some tests, this is what will actually drive those tests. So you'll start with a requirements-driven happy path, kind of typical manual test strip. It'll run through that, give you your feedback, but then there's a intelligent engine that can take over, and it can be set to bias either towards coverage. So in this fairly simple example here, a lot of states, a lot of screens, a lot of ways to get from one screen to the next. So how do you ensure that you're testing all of those different paths and ensuring that you get code coverage? And then alternatively, you can also set it to be biased towards bug hunting, which, as we discussed earlier, is really that way to set a system in the corner and let the system go do kind of automated exploratory testing. And really, when you look at either coverage or automated exploratory, we're really talking about managing risk? How are you ensuring that you're covering your code, you're covering state transitions, you're identifying specific areas and really drilling into those, and at the end of the day, being able to pass on with some certainty a fixed level of risk, ensuring that you meet your the risk requirements or parameters for that particular system. And then we also have something called the Eggplant Manager. And what that does is that's really a synthesis engine. So that's where it brings a lot of things together, allows you to schedule time and systems under test, run multi-parallel testing, either against multiple devices or the same device, and able to code and test faster because you can parallelize those tests and get more results from just the basis of running more tests. That all goes in a repository, the metrics and the ability to really see real time what the status of any given test run is, what the status of any particular program or application is, and be able to share that across up and down the chain, again, trying to get that DevOps communication to really come from the operators and the users all the way back to the developers. We, again, have a very open ecosystem. So whether you're looking at the tools that make up your ALM and test management environment, whether you're starting to run a CI or a DevOps tool chain with things like Jenkins or Hudson's, you've got Puppet doing your configuration management. Maybe it's in your build side using Maven or Ant. All those tools will fit in. We can call them, we can be called by them. So it really closes in nicely and fits well within your current environment. And then there's a sampling at the bottom there of our domain-specific tools that we can work with. And again, small snapshots. So if you have other ones you're curious about, contact us. We're happy to work with you. If we haven't done it before, we'd certainly welcome the opportunity to work with you and prove that out. So that takes us to really kind of the topic of the day, which is our automation intelligence specific to defense and security, and some of those challenges that we spoke about at the top of the hour. Probably the most important is how do you test in terms of the user journeys with an eye towards desired mission outcomes. Complicated systems, professional and talented users, high stakes. All that comes together to create an environment where it's really, really important to ensure that the software that comes out of the developer's environment meets the needs and delivers the required outcomes in the field. And this, again, is done by our automation intelligence, our ability to model an application to any level of detail required, track those paths, and then use the engine to run through and ensure you've got coverage, ensure that you know, beside the happy path testing, a user under stress may do things that are unpredictable, may move from screen to screen in an erratic fashion. How do you ensure that the system is stable through all those? And really, you only get there through automating use cases and test cases well beyond what you could ever write if you just set up a bunch of test architects to write a bunch of manual tests. Again, in the environments we work in, how do we anticipate those real-world stress and unplanned scenarios that you have when you have an operator working under a heavy level of stress, heavy level of uncertainty with, you know, in this case, lives, or in the space case, you know, money in peril of any kind of failure. So what that really does is again, goes back to that AI-assisted automation, right? We get the test scripts built, we get the model built, and in this case, what we've got running here is a quick video of a video game, and this shows a couple things. It shows our test tools and our test suite running against a complicated interface. In this case, he's actually connected to a console. A little bit later in the animation, he'll switch and he'll actually run the same test against the PC version to show, again, that you don't need to build a new test just because the version or the device changes. And then you can see in real time on the side, the model. As we run through this, you'll notice that the blue and the colors change in the flow chart as the system works its way through the various journeys. You've got a runtime window that's showing your script as it's running and the outcome. And then on the screen, you see the actual system under test being driven by Eggplant, functional executing the test, and AI driving it. Once the test is run, you can switch over to a coverage report. You can get a first look that is exportable. Basically, you can dump that into Excel and manipulate that, but you can also switch over to what you just saw there, which was a coverage where the model actually shows you where the coverage was strongest, where the gaps were, in a very visual way. Now you see you switched over to the PC version, running basically the same script and interacting with the system the same way, and we'll have the same type of report and the same type of feedback from that system as well. Anytime there's exceptions in any of the testing, the screenshots are taken, the steps that got to that state are taken, and everything is put in an easily accessible and transferable archive that the developers can go and actually see what caused the problem, as opposed to, again, having a manual tester manually document the steps they took in the descriptions. So again, taking the human out of the loop in that case. Enabling third-party testing. Pure black box. A lot of systems have protected IP, either at the internal level, or in the case of large acquisition programs, you'll have maybe a handful of SIs working on different aspects. So not always will you have access to the underlying code. And really what's important from our perspective, again, is that user experience. It says, once we get the systems all put together, does it deliver in the field as intended? And by hooking into the software the way we do, by being able to capture and animate complex graphical user interfaces, we can pull all that together and drive that in an automated fashion. When you run through these kind of systems, again, there are certain errors that nobody wants to see. If they're trying to call in an airstrike, asking for close air support, trying to redirect a sortie or redirect a mission, things that maybe wouldn't normally be tested, by letting the system run, looking for edge and corner cases, you can find some things that wouldn't typically show up. And that, again, just comes from that idea of testing the end user experience through the UI across the platforms, devices, modes, client server, mainframe, embedded, like we talked about, and then that device automation we talked about in the cloud to allow you to parallelize test and, again, save time. As we think about moving into more agile development, into iterative delivery, how do you know when that product or when that particular piece of software has reached that minimally viable category to be able to release into testing? Based on our experience, based on what we capture in your environment, as well as what we've learned over the many years of testing we do, we've got some predictive analytics, some proprietary algorithms and stuff that really can take a look at any piece of code and give you some nice charts you can drill down into, some dashboard and some what-if analysis tools to help you make those decisions of when you put a version into user acceptance testing. And then lastly, how do we close down and close that loop on mission progress and recommended improvements? So with the analytics that we're able to do, with the real-time user monitoring, or in some cases an artificial intelligent agent, synthetic agent we call it, running these tests, you'll get a ton of data that you can drill into. We can go into this in more detail in later webinars, but again, once this is all done and executed, the way the data is captured and the tools are able to analyze it, again, a big time saver for addressing the most important things when it comes to either building new capabilities or looking at regression testing or addressing bugs that have been found in the field. So as a way to kind of recap where we were and what we've covered, addressing those challenges unique to the aerospace and defense market and preparing you guys to what's coming and kind of some acquisition changes, how do we bring domain experts into the conversation? Have them work with us on the model. It's codeless. Again, not looking for software developers here. We're looking for user experts. Using animation intelligence and machine learning to assist in that automation, and not only the execution, but the developing of multiple test cases, again, either functioning towards coverage or that automated bug hunting or automated exploratory. Non-invasive, any system, anything with a UI, no clients, no need to hook up anything, touch system under test, industry standard remote protocols drive the test, and the system under test therefore is acting in its native environment. And really those three just point to our vision again. We want to test the user experience. Is it really doing what the users needed to do? Mission success is really key, and we want to keep that in the front and center. And once all that's done, you've got a nice collection of data for the predictive analytics, not only for determining when to release, but also how to prioritize backlog work for either current version sustainment or next version release. Okay, thanks. I appreciate everybody's time. Look forward to seeing some more webinars. This will be a series, so this is kind of an overview intro, and then as we go forward, we'll be breaking down for a little deeper dive into each of the components that make up our suite, and also look at some real-world examples and possibly some customer case studies that we can share to show some real-world ROI of automating your environment, or at least your testing environment, really from end to end. You've got our contact information on the screen there. Please make a note of this, reach out to us. Again, my name's Jim Nickel. I run our aerospace and defense business for the US, and my peer Tim Haythorne is doing the same over in the UK. So depending on where you are, reach out to either one of us, and we'd be happy to have a further conversation, talk about your unique needs, or possibly see if we can't get an evaluation up and running and let you guys get your hands on the system. Thanks again, and we certainly look forward to hearing from you. So reach out to us and let us know how we can help.